So in this section, we're going to work with using inverse trigonometric functions. It's important not to be confused about, this is not talking about the fact that cosecant is the inverse of sine. That's not what we're talking about. Okay, so this is not what we're talking about when we're talking about inverse functions. Inverse sine would be written this way, sine to the -1 power of theta, or cosine to the -1 power of theta, or tangent. And you have keys for this on your calculator. Okay, and what that looks like, let me put out my calculator, is it looks like this, inverse sine. Now, when we're talking about inverse trig functions, the purpose of an inverse trig function is to do the opposite thing than we did with the original trig function. So when I have an angle and I use the sine key, it tells me the sine of the angle. When I use the inverse sine key, it's because I know the sine of the angle and I want to know what angle it was. So one allows you to find sine based on knowing the angle, and the inverse trig function lets you find the angle based on knowing its sine or its cosine or its tangent. Okay, so that's what we're going to work with in this particular section. So one item, problem we might solve using this would be this item with a monster truck. It's jumping off a ramp. The ramp has a height of 8 feet and a horizontal length of 20 feet. What is the angle? Okay, so we may understand the run and the rise, and how are we then going to figure out what is the actual angle that's being created and modeled in this problem. So we'll finish this up. We'll solve this problem at the end of the lecture, but for now let's talk about some of these ideas. One thing that becomes complicated when you use inverse trig functions is if you look over here, right, when we start talking about the sine of an angle, sine is again related to y. I could have an angle here and an angle here, and with a horizontal line, those are both going to have the same y value, which means they're going to have the same sine. Okay, so then I don't necessarily know, I would have a difficult time knowing which one of those angles is the one that we're talking about. Okay, so typically in a problem like this, you're going to get a little extra information where they tell you something like this. Theta is between -pi/2 and pi/2. In that case, I would only have one angle that had that particular value of sine. Okay, so they have to give you a little extra information. And it's the same with cosine. If I put a vertical line through here, through quadrants 1 and 4, because cosine is related to x, each of these items, each of these points, because cosine is related to x, each of these points here have the same x coordinate. So I couldn't determine what angle it was if I was working in quadrants 1 and 4 because there are two angles that would have that value. But here, if they net it down to being quadrants 1 and 2, then I can say, oh, definitely, because this one would be positive and the other would be negative. Okay, so there's always going to be this extra piece of information that helps you figure out where are we talking about. And normally what it does is it eliminates half of the unit circle by the rule that's sort of placed in on here. Okay, so that's an added element that we're going to be working with. If I just want to look at an inverse trig function and I want to find the inverse, so sine, what this tells me is if sine, when you're talking about an inverse function, if the sine of theta is equal to 1/2, then theta equals what? So that's what the trig function, inverse trig function allows me to do. So if I pull out my handy dandy calculator, right, and I do 0.5 inverse sine, it tells me it's 30 degrees. Okay, and I'm working in degrees. If I wanted to change it into radians, I can turn my radians on and off here. So if we go 0.5 inverse sine in radians, interesting, right? Never mind. Take that out. If I want to do the inverse sine where tangent is -1, I can pull out my calculator and say, okay, so if I have the opposite of 1, what is the inverse tangent? Well, it's -45. Okay, that would be, that's the reference angle, -45. So where's -45 degrees located? It's down here, right? So this is the angle we'd be talking about. So -45 degrees. So go ahead and practice doing this. Do problems 3 and 7 and 12 and 16. 12 and 16 will be working with angles that are not standard angles. 3 and 7 will work with standard angles. 12 and 16 will work with angles that are not standard. So practice that out and then come on back to the lecture. So here, sine of theta is equal to -0.45 degrees. Or -0.45, excuse me, not degrees. So if I pull up 0.45 and I find the opposite of that, and then I find the inverse sine, I get -26.74 degrees. So let's go ahead and talk about that. -26.74 degrees. 26.74 degrees. Right, and we're saying that the theta is going to be between 180 and 270 degrees. So what they've given me here is this reference angle, 26.74. So what's the angle that we actually have here? So this negative item doesn't really apply. So this is going to be 206 degrees, 0.74 degrees is what's going to give me this value. If I take 206.74 and I find sine, you see I get -0.45. Okay, so sometimes the way the negatives and things come up, what's important, feel a little uncomfortable. What's important to remember is the angle you're getting out of your calculator is a reference angle. And if I place that reference angle in the correct quadrant, then I'll be okay. Okay, so when we look at this item here, we have 360 degrees here and 270 here. So this item here tells me I'm in quadrant 4. Now if I go ahead and find where's cosine 0.25, so I do 0.25 and I find the inverse cosine, it says 75.52 degrees. So that means I'm going to go this direction, 75.52 degrees. So it will be 360 degrees minus that. So here I'll get 48. 9 minus 5 is 4. And then 35 minus 7. 35 minus 7 is 28. So 284.48. If I want to go ahead and double check that to make sure, 284.48, and I find cosine, you'll see I get 0.25. Okay, so that checks out. All right, let me write this a little more clearly. 284.48. Okay, so go ahead and practice that. Do problems 20, 22, 27, and 28. And then pop on back, we'll solve the problem about the truck ramp. Okay, so here I have this ramp. right? And I have this ramp, and it goes like this, right? And I know that the height is 8 feet, and I know that the length is 20 feet. All right, so if I'm talking about this angle here, what do I have? I have the side opposite, and I have the side adjacent, so I know that the tangent will be equal to 8 over 20. And if I go ahead and start simplifying this, that's going to be, right, if I take 4 out of that and 4 out of that, I'll get 2/5, which would be equal to 0.4. Okay, so if I want to know the angle, I can go back and say, okay, if my tangent was 0.4, then what was the angle that had that? And it's 21.8 degrees. Okay, so I know that theta in this case is equal to 21.8 degrees. Again, I did this by calculating the tangent and then using the inverse tangent function to find the angle.